Okay, some more solving polynomial equations by factoring, and this is 2r squared plus 2 times the quantity, in parentheses r squared, plus 1 equals 5r, so this is a nice problem. First of all, we have to remove the parentheses, so we have 2r squared plus 2 equals 5r, and then we want to set it equal to 0, so we'll subtract 5r from both sides. So we have 2r squared minus 5r plus 2 equals 0. So now we have a general trinomial, and we can use our general trinomial method. But since we have a 2 here, the only way we can get r squared is 2 times r, or 2r times r. So we can try to do this kind of by noodling it out. This is 2r, and this is r. And the reason why is because this sign is positive. That means these signs must be the same. And since they had to be negative, they both must be negative. So that's going to make our work a little bit easier. And there's only one way to get 2, 1 times 2. So we just have to figure out whether the 2 is going to go here or here. So it's just a couple of possibilities. If I put the 2 here, I get minus 4. And if I put 1 here, I get minus 1. So it kind of works. If I put the 2 there, it wouldn't work. I get 2r, and minus 2 would be minus 4. If I put a 2 here, I'm sorry, if I put a 2 here and a 1 here, you got to get minus 2 and minus 1, I guess, if I put the 1 here. Well, either way, if I put the 2 here, I'm going to get negative 4r, and if I put the 1 there, I'll get negative r, and that works. If I put it the other way, it wouldn't work. All right? And we can always check it. Always check it. Negative 2r squared, and this is going to be a negative 4r, and negative 1r is negative 5r, and that's going to be a positive 2. So you can kind of noodle some of these out if they're easy in this part. Okay? So now we know that either 2r minus 1 equals 0, or r minus 2 equals 0. So 2r equals 1, so r equals 1/2, or r equals 2. So your solution set is just 1/2, 2. Okay? And then 26. Well, this is already factored out. We've got x plus 2 and x squared minus 4, and it's equal to 0. If it was equal to another number, then we'd have to do a lot more work and multiply it out and shift it around. But it's equal to 0, so it's already set to go. So we know that either x plus 2 equals 0, or x squared minus 4 equals 0. And actually, I should have factored this out first, because I know I can factor this, because this is the difference of perfect squares, so that's x and 2. So sorry about that. I should have factored that out, because this really wasn't completely factored, because this is going to be and it's going to be the product of the sum and the difference of these little numbers, because this is the difference of perfect squares, remember that. So it's going to be x plus 2 times x minus 2. I could have done it up here, and I should have done it up here, but this would work fine. So now we have a possibility here that x equals negative 2. And over here, we know that either x plus 2 equals 0, or x minus 2 equals 0. All right? So here x equals negative 2, and x equals positive 2. Now notice we've got negative 2 twice. Okay? That's what we call a repeated root, and we'll talk about that later when we're graphing it. But right now we only have 2 unique solutions, negative 2 and 2. And again, like I said, this is called a repeated root, and it just doesn't disappear. It's important, but like I said, we'll talk about the ramifications of that later. So that's number 26. And number 28. And you could always pause these and go back. Number 28, we've got x to the 4th minus 2x squared plus 1 equals 0. Now this is a polynomial in x squared rather than x. So we could actually just, it's a simple trinomial in x squared. Because the only way we can get x, well, the way we're normally going to get x to the fourth is x squared times x squared. X squared times x squared is x to the fourth, and then you'll see if we combine these, we'll have x squares. So then we just analyze our signs. So it's really a simple trinomial. It's just, instead of having x's and x's here, we've got x squares, x to the fourth, and x squares here. Okay. So if that makes sense. We did these with a z substitution also, but I think you could do this without. Now, my signs are going to be, this tells me that these signs will be the same, and if they're the same, this tells me what they are. They're both negative. And they have to multiply to give 1. There's only one way we can get 1, and that's 1 times 1. And actually, it's a trinomial square. I should have noticed that because the square root of this is x squared, and the square root of 1 is 1, and we have twice the product in the middle, so that's what it is. So again, we've got some what we call repeated roots, but we won't talk about that right now. We'll just say that we have, if we factor this, this is going to be, well, the square root of x is x, and the square root of 1 is 1. Same thing here. So we have the same thing. So we've got, if we factor this out, this is x plus 1 times x minus 1, and this is also x plus 1 times x minus 1. And we've got 2x plus 1, so we know that x plus 1 equals 0, so x equals negative 1. And again, these are repeated roots. And then we've got 2x minus 1, so we can just say that x minus 1 equals 0. This should be or, excuse me. X would equal positive 1. So your solution set is negative 1, positive 1. But again, we do have what we call repeated roots. Okay.